This is today's daily lead code. So minimize the maximum difference between of pairs. Minimize the maximum difference of pairs. So there are pairs, they have difference, and there will be so many pairs, there will be so many difference. So consider the maximum of them. You have to minimize the maximum of that. So okay, whenever maximum minimum kind of things occurs, binary search is the way to go. But first read out the problem. That is also the thing. The pairs return the maximum difference of pay. We define the maximum difference set as 0. Okay, so not the pair yeah. So that is just the difference between pair is considered as absolute value of the difference. Yes, and zero understand what can we do? Can we like try to do something to minimize or yeah? P and S is the maximum difference. So sure, you cannot do anything as such like to modify the array, but you can do one thing which is to optimally take elements. I think zero index then p and p pairs is the maximum pair. Yeah, so you have to just find those optimal p pairs that such that the difference between the pairs and then maximum of them is minimized. So like you have to just be more smart in taking elements. So by smart I mean like you take one when and you take two three, so that's how you got like zero and then over here you can get two two and you have to take only one pair. So yeah, take two two, which is zero. So n square element, n square basically you can do pairs and then you can see that n square. So for each element you can see that what is the nearest element. You can just sort it, and the thing is that yeah, just sort it, and then adjacent element will be your pairs and they will have the minimum possible sum. And just yeah, find the as I did over here, so sorted it, and then go from yeah one to n, or basically just slice every adjacent element. They are your potential pair. And just consider, you cannot say that initial k elements will be my p elements, or okay, initial p elements will be my final like the answer, because it's guaranteed that this 2 and 2 are smaller, like 2 and 4 are smaller as compared to 9, 8 or 10. But you cannot guarantee that 2 minus 4 is lesser than 9 minus 9, right? 8 minus 8 or something like okay, if it's sorted, so let's consider this also as 10. So these two pair will be the smallest. Even if this is the complete array, you cannot take like 2 comma 4. Yeah, so that's basically, you understand, like you have to just go on every adjacent element, you call it as pair, and then you see the difference and then you return. Yeah, use like kind of like yeah, you just store them somewhere or something like that, or yeah, because you have to return p of them, store them in mean heap, max heap, something like that, so that you get at least p equal to 2. Why I'm saying min heap max heap? Because you know, like if you store all blindly in a min heap, then you get minimum sort, like yeah, min heap is sorted in a way that top element is the minimum and so on. So then take out the first p elements from just first top p elements from the min heap, or you can do max heap to create a size of, just to fix your size, that okay, the only I'm gonna push only p elements. If something else comes that is better than this p elements in max heap, then I replace that. Okay, what I mean by that, because like the in max heap my topmost element is going to be my maximum. I see that my current element is lesser than maximum, so remove the maximum, push this in. Yeah, so that's how you can do. But how I did over here, I think you got maximum, minimum, and then while mid. Okay, I did something like a binary source kind of thing, but min heap max heap you can do. uh yeah, another thing what you can do, okay, okay, then you can go for like yeah, like okay, minimum and maximum, this is the pair difference. So yeah, this is the maximum pair difference between all, and this is the minimum pair difference between all. So this is the range of your the final pair difference which you can get, which is actually the optimal pair yeah, if you take the optimal thing, then this min can be also yours, but in worst case this max can also be yours. If you have to take all the pairs, then the answer is maximum. If you take only one, then minimum is your answer, and you know like how many you have to take. So yeah, one thing I also said that yeah, why not do that, like, or push all the pairs or difference what I'm getting, like this ai minus 1, push all this into a vector, then sort that vector and then take up. That is the same as like doing and same as doing like min heap. So yeah, that's about it. Okay guys, bye. Or DSA course, let's continue and let's see some of the problems from the DSA course.